We proceed to our next question, question number 2. The displacement from a fixed point of a particle in motion at any time t seconds is given by, displacement s is given by t cubed minus 5 over 2 t squared plus 2t plus 5. The value is in meters. Find its acceleration after t seconds. Find acceleration after t seconds. Acceleration is given by change in velocity from the mathematical formulas divided by change in time. But velocity, we saw earlier also, is given by change in displacement divided by change in time. Therefore, for us to get acceleration, we will have to get velocity first. We have to get velocity first. So for us to get velocity when we are given displacement s, we differentiate. We differentiate s with respect to t. Therefore, we will have the s dt, which will give us the velocity. So the velocity becomes, when you differentiate t cubed, you bring 3 down into t, then 3 minus 1, minus, bring 2 down, that is 2 into 5 divided by 2, t into 2 minus 1, plus 2t 1 minus 1. When you differentiate any number, you get 0, plus 0. Therefore, we have ds dt, which is our velocity, equals to 3t squared. 3 minus 2 is 2. 3 minus 1 is 2. Minus 2 can cancel with 2. You get 5. T raised to power 1, which is 5t. Plus 2t raised to power 0. T raised to power 0 is 1. Therefore, 1 times 2 is 2. So this is our velocity. Now, we know our velocity is 3t squared minus 5t plus 2. We want to find the acceleration. And we said acceleration is change in velocity divided by change in time. Therefore, for us to get the acceleration, we are going to further differentiate the velocity, which will give us dv dt. So this gives us the acceleration, equals to, further differentiate this, you bring 2 down, multiply by 3, then t squared minus 1, minus 5 into t1 minus 1. This is 0. So our acceleration equals to 6t minus, this is 6t raised to power 1, which is 60, minus 5t raised to power 0 is 5, because we say that t raised to power 0 is 1. So this is our acceleration. But what is the question saying? Find the acceleration after t seconds, because the question is not specific within which time. Therefore, we just say the acceleration is given by 60 minus 5, but the units is very important. The SI unit of acceleration is meters per second squared. Meters per second, which is meters per second squared. The part B of the question says that find the velocity when acceleration is 0. When acceleration is 0, where is our acceleration? This is our acceleration, the equation. So at this point, when acceleration is 0, we have 60 minus 5. We want to find the value of t. T is equal to, when 5 crosses the other side becomes positive, 60 is equal to 5. This gives us t, value of t, as 5 over 6 seconds. But this is t, although the question wants velocity when acceleration is 0. Therefore, velocity from our question is here. Let me come here. Velocity from our equation is here, 3t squared minus 5t plus 2. From here, velocity is equal to 3, but the value of our t is 5 divided by 6, it's squared, minus 5 into 5 divided by 6 plus 2. So from here our velocity equals to 3, 5 divided by 6, 5 squared is 25, 6 squared is 36, minus 5 times 5 is 25 over 6 plus 2. So velocity is equal to 3 goes here once, 3 goes here 12 times. So we have 25 over 12 minus 25 over 6 plus 2 over 1. You can either use a calculator to solve this or get the LCM of 12, 6, and 1. Least common multiple, which is 12. 12 goes into 12 once, times 25 is 25, minus 12 into 6 into 12 twice, times 25 is 50, plus 1 goes into 12 times 2 is 24. When you simplify this, velocity is equal to 25 plus 24 is 49, minus 50 divided by 12. So velocity is equal to minus 1 over 12 meters per second. And remember, I told you when the velocity is negative, it means that the body is retardating. So you write velocity is 1 over 12 meters per second, but you write retardation. So we are done with the questions on differentiation. Our next question is on trigonometry. So question number 3. Trigonometry, we are told to solve the equation sine of 2 theta plus 10 equals to negative 0.5. But we are further advised for the values of theta less than 0, less than or equal to 0, and not greater than 2 pi radians. This sign means pi radians. So we want to find the values of theta. Number 1, find an angle whose sine is 0.5. Find an angle whose sine is 0.5. So which angle is that? From your 4-figure elementary mathematical table, if you can get an angle from the calculator, the angle whose sine is 0.5, that angle is 30 degrees. Therefore, the first thing we do is to identify all the quadrants where that angle lies. But remember, we have negative here. So when we draw the quadrants, we say all, when I was in my Form 4, I used to remember it as all Christians terrorizing Satan. Or all students take coffee. Not changa, don't put here as changa. So this angle is 0 degrees, this is 90 degrees, this angle is 180 degrees, this angle is 270 degrees, and this angle again is 360 degrees. So this quadrant circle, we want to find an angle, all the quadrants where the sine is negative. So in quadrant number 1, this is all angles. This one is sine, this is tangent, this is cosine. So all angles in the first quadrant, all trigonometric functions in first quadrant, they are all positive. Sine is only positive in the second quadrant, tangent is positive in third, cosine is positive in fourth. But sine is positive only in the first and the second quadrant, although it is negative in the third and the fourth quadrant. So our angle 30 degrees lies somewhere here. So if our angle is lying here 30 degrees, we cannot write it as 30 degrees because 30 degrees is only positive in the first quadrant. Therefore, in the third quadrant, we will make a half a rotation to reach where that 30 is, half plus 30 degrees. So when you make half a rotation, that is 180 degrees plus 30, you get 210 degrees. Therefore, 2 theta plus 10, our first angle is 180 plus 30, which is 210. Our second angle, if we say that sine, if the angle is 30 degrees, what is the value of this angle? That is 360 minus 30 degrees. You get 330 degrees. Then something interesting, you make one complete rotation. Then you add to the available angles, so that we get all the angles, because we've been told that our theta is greater than 0 but less than 2 pi radians. So when you take 360 and you add 210, you get 570, which is another angle. And then you add 360 here, you get 690, which is our other angle. These are in degrees. Therefore, when we open this, we get 2 theta equals to, when 10 crosses the other side, becomes 200, because it is 210 minus 10. 330 minus 10 is 320. 570 minus 10 is 560. And finally, 690 minus 10 is 680. They are in degrees. Therefore, theta is equal to, divide everything by 2, 2 into 200, 100 degrees. 2 into 320 is 160 degrees. 2 into 560 is 280 degrees. And 2 into 680 is 340 degrees. These are the answers. But remember, we are told to write our answers in pi radians. Common rule in maths, 1 pi radian equals to 180 degrees. When you move from 0 to 180 degrees, you've made a pi radian. Therefore, we want to convert this. If 180 degrees equals to pi radians, what about all these angles? What about 100? What about 160? What about 280? What about 340 degrees? So you realize that we'll be multiplying 100 times pi, divide by 180. 160 times pi radians, divide by 180. 280 times pi radians, divide by 180. 340 times pi radians, divide by 180. So we divide all these angles by 180. So we'll have 100 divided by 180, 160 divided by 180, 280 divided by 180, and finally 340 divided by 180. They're in degrees. So when we simplify this further, 2 here 5, 2 here 9. So you get 5 over 9 pi, 2 here 8, 2 here 9. 8 over 9 pi radians, 2 here 9, 2 here 14. 14 over 9 pi radians, 2 here 9, 2 here 17. 17 over 9 pi radians. So this is our final answer, which is in the range of theta being greater than 0, but being less than 2 pi radians. So you leave your answer in pi radians. So we can proceed to the next question. If I were to mark this just a little bit, assuming that I'm an examiner also, my first question I would give you for identifying that angle as method 1. My first method 1. Number 2, I would reward you for getting all the angles, which is method 2. Number 3, I would reward you for the conversion, the process of converting, which is method 3. And then finally, answer 1. So in this question, you would harvest 4 marks. So learners, candidates, you can see maths is like eating yams. It's very easy. Very easy, just like reciting vowels or snatching a lollipop from a baby.